let's continue our third lecture on programming languages on syntax. So yeah, while on the break, I was looking at the old computers. So this is the IBM computer. Well, it's an electromechanical computer. Actually, I think called SSCEC. And so you can see, if you look at this here, it is programmed basically a whole bunch of switches. All the lights and all these switches. I mean, so you set basically, I guess you set all the bits and all these. I mean, I suppose there's certain coolness to this, but I mean, programming anything complicated would be very, very painful, right? So I suppose you get output here, right? And this is what you use to program it, right? But this is not this is electromechanical computer. I think the last commercial like electromechanical computer from IBM, right? Why is it important in context of programming languages? Because people complained it is pain to program, right? And so it led to John Backus, I believe. Yeah, John Backus, yeah. So John Backus, this guy here, this serious looking guy, right? He invented the Fortran, right? He got Turing Prize for that, basically, right? But he also came up with Backus Naur form along with Naur. Where's Peter Naur? I think Danish one, right? So, together, right? They came up with this way of specifying a syntax of a language, right? So, and we will look at it right now. So, what's the issue? Right, so we need some way of generating basically looping. We need something to loop. How to loop, right? How do we loop? Loop, right? So this is a formal way. So it turns out that the solutions they came up with, right? Again, I'm sure they were aware of what Chomsky was doing with the languages at the time, right? And some ideas. Very extremely simple concept, actually, right? So let's take a look at what they came up with. So I'll make another paint, right? We have lots of paint. So idea is to have two type of symbols, right? Non-terminal and terminal, right? So basically, right? So you have some, you come up, you build this BNF, right? You basically come up with some production rules, right? So basically it's rules, production, right? It's like factory. Production rules, right? So, and I'm gonna like, on the left side is something called non-terminal symbol. So what's a non-terminal? It's basically
the one that can be translated.
Yeah, it's gonna go away. It's gonna, you're not gonna see it. So non-terminal, you're not gonna see it in your final code, right? It's gonna be go away. Eventually, it will disappear, right? So how does it disappear? Well, there's gonna be these production rules. It's gonna be replaced by something, right? So what can be replaced? It can be replaced by another non-terminal, right? But it can also be replaced by a terminal, right? Symbol. So what terminal means doesn't mean like a terminal we type on, but it means a symbol which is the final, like what you see on the screen. So it could be a letter, it could be a number, it could be plus, minus, pretty much anything you can see on a screen in real life, right? It would be a terminal symbol, right? So non-terminals, right? Non-terminal with another non-terminal, right? Another non-terminal, right? Or it could be with terminal. I'll call it terminal, right? Something like, say, you know, A, right? That's a terminal, right? That's terminal symbol. Terminal symbol. I love my writing. All right, so now notice this invention here. So that's like basically OR, right? So here you say, okay, there's some non-terminal symbol. It can be replaced another non-terminal, or it can be replaced by a terminal symbol. Okay, and that's basically it. But then how can we describe a language? Well, when I say another non-terminal, what does it mean? It can be also this one here, right? So we could have a combination actually, for example, right? So let's see how we could write let's say, how could we define a digit, for example, a number, an integer. Let's come up with an integer. Let's come up with an integer, right? So, what's an integer, right? Well, let's define digit first. Digits will be very easy. What's a digit? Right, I'll use something like this. So digit is basically digit, right? This is a non-terminal symbol. We don't know what it is, but and now basically we could use some sort of like, we could use typically it's used like this. Yeah, that's one way of, it's a rule basically, or you could use like an arrow or something. Sometimes use this or this. Oh, this is the most common because you write like so. What makes digit? Basically, 0 or 1, right? Or 2. And the bad news for you guys, well, I guess the good news for you, but if I made you write BNF, right, you will have to write all of the digits. You don't have a shorthand way of doing it. This is a classical BNF, like the one from late 50s, right? Which luckily most people don't use anymore because it gets really kind of painful to use, even though it's simple, right? But then, so, right? You get the idea, but this is where actually on a midterm, right? You're gonna have to write some BNF or eBNF, right? This or homework, right? This is not valid BNF, right? Just because I'm lazy, I'm not gonna let you be lazy, right? So yeah, I've seen some people write this, right? And they, okay, yeah, no, this is not BNF, right? Because the computer is not smart enough. I mean, a large language model might figure out what you meant here, right? But that is not gonna pass the, it's 3, 4, 5, 6, 7, right? 8, is it included? Right? Be explicit, right? Here, right? As defined. Well, this would not be a valid definition of BNF, but if I skip this part, it will take only 0, 1, 2, and 9, right? 3 to 8 would not be accepted, right? Okay, but you get the idea, right? Everyone knows how to make a digit, right? But how do you make an integer? And so this is the beauty, I guess the big invention is this. So let's do an integer, right? Integer, right? So again, I'll use this syntax, right? Okay. Integer could be, what's the smallest, what's like the most basic integer would be a single digit, right? So let's do that. Digit, right? Right? But that would not be enough. So how could we make it basically? How could we make it make a longer? How would we make a longer integer?
Or we could add a non-terminal.
Yeah.
That would then could be
another
digit plus the same on non-terminal.
Yes.
Terminal.
So and the beauty is here we basically what we do is basically, if you remember our talk of recursion, right? We can use recursion to make loops. So what's it gonna do? We're gonna do this one here, right? Right? We're gonna use. We don't have to, but we can use the easy trick is to integer, right, plus digit, and that's it. And that's it. So it's a recursion. And that turns out this is all you need. So basically, right, so the question is, okay, so is this, so if I said integer is just a digit, right? Right? That's we stop because remember this is OR, right? That's like the base case, right? Eventually, well, again, so this lets you do infinite integers, right? Any size, right? 50.
But wouldn't there be an edge case where, well, let's say the first digit is 1, and then you could put the second as 0. 0, 1 would be kind of.
Yeah, it would be accepted basically, right? 0, 0, 0, like this would accept, right? This is not a very, at the moment it's kind of very, it lets you put like 5,000 zeros in front of 1, right, or 50, you know. So it will work even, you know, it will work. So this is, you know, 5 is okay, right? It will work with this, right? But otherwise, so that's the only problem with this definition of an integer, right? You know, but if you're fine with this, right? Who cares about the zeros anyways, right? So you accept, you're sort of like very liberal here. Okay, you want to put some zeros, some leading zeros in front of your numbers? Go ahead, knock yourself out. So how could we make this known? Well, so this is kind of gets a little bit trickier. How could we come up with a specification, knowing what we know here, to have not allow these zeros, right? So we can only allow 1 0, right? So how could we do this, right? So now I'm trying to remember again. I don't remember this offhand. Does BNF let you have multi? No, it lets you, right? So we can do this, right? It can start with. So how do we make it have a special case, right? It could start with it could be basically single zero, basically, right? We could add just single zero, but then how could we make it not start with 0, right? And then we can let it start with anything. We probably need some, again, you're allowed to make as many non-terminals as you want. You know, 50,000, knock yourself out, right? So that would be a good challenge, actually, right?
I mean, we would likely have to invent a new non-terminal,
yes.
I think.
Yes, I think, because otherwise it will not work with the classical BNF, right?
Yes.
Because, yeah, so this is a good catch, right? So this is, yeah. And you can see these two rules, right? Again, you are just checking. Remember, you're not trying to generate. You are checking. This is for syntax checking something that already exists, right? So if it's digit, right, you check, right? So you come up with these production rules. Integer, right? It goes back. Oh, okay. Eventually, right? Eventually, you replace all of these with basically. You know, eventually turns out, hopefully, right? So that's the way. This is the basic idea. So now let's see how we could make we have integers, right? How about arithmetic, right? So I guess I'll do paint, another paint, right? Too much paint here, right? So operator would be easy, right? So we could define also terminal, right? So let's do operators. Operators are really easy, right? And some of you did this in your homework, or in C++, right? Right? Yeah, you did. Some of you did this, right? So operator, right? And now you know the trick, right? Plus or minus, right? And so you have a nice little, that's operator. So this is non-terminal, these are terminals, right? So again, if you didn't care about the arithmetic, you could add, of course, other operators here, like division or multiplication. But things will get trickier when you want to get those, right? You want to do it correctly, right? So for now, we'll stick with these, right? So we have the digits. We have the digits here somewhere, right? Yeah, we have the digits. Now we have the operator, right? Lots of paint. Now, and I guess we will need so operators, integers. Can we get by with? Now let's see if I can do this without anything else. I think I'll need one more non-terminal, right? I think I have it written here because it's going to get hard, right? So I'll need one more terminal. Let's see if I have it here in my, presentation. Where's my presentation? Oh, there we go. Oh, reconnect. Okay. So yeah. So expression, right? We'll need to have a factor. This is actually full. So number, right? Yeah, we have that. So an operator, right? So what's it? So we come up with something called the terminal, right? So what's a terminal would be, I'll call this term. it's not strictly needed here. I'll call this, it could be a number, right? Or integer for now, right? So you can see in here, this is kind of like a, you know, sort of like a catch, you know, it lets you add some more if you want, you know, maybe float, maybe string, whatever, right? But for now, just an integer, right? So, valid expression, right? What's a valid expression, right? Let's see if I'm doing this from my, you know, like from my head. So, could be what? A terminal, right? This would be fine. All right, or let's think about this now, right? Or terminal operation on terminal, right? If I do it correctly, and let's see. But that's not enough, right? Let's see, is that actually right? But you still have the problem.
Terminal operator
Expression? I think.
Yes.
I think this is what we do. Yeah, because we want the right. We want the loop. We want the recursion. Otherwise, it will not. I mean, otherwise, because now we can. Now I think it's enough, right? Now if we can do simple arithmetic, right? Expression, right? Oh no, there's no. We can keep building, right? So yeah, and that's actually I think is enough. I think that's enough. Yeah. Or now the question is, or maybe I had to do it reverse. Now, is this going to be a problem? Or maybe I do it, or maybe expression operator. Yeah, that's the thing. Which one goes first, right? Operator term, right? Term, right? Maybe this one is actually the correct one. Let's see. And where's my cheat sheet, right? Oh, there we go, right? And yeah, term, right? Expression, right? Term plus term, term minus term, or just term, actually, right? So you actually can do it like this in terms or a factor, right? Factor expression, right? So let's see, do we have any more? So Backus Naur, right? So yeah, this is actually what we talked about, right? So. Again, so non-terminals basically represent something like a expression, like a variable statement, right? So rules, right? So recursion, right? So context free gamma, right? So yeah, this we all talked about. So there's again, so one thing is there are multiple ways of getting to the end, right? So again, so number, right? We did this already. Right, this is a little bit more, right? This has also multiplication, right? Has something called factor, right? Also, you can do in a factor. You can also have a parenthesis, right? Something this lets you use parentheses as well. So this is something the full grammar for the harder homework for number 10, actually, right? So, but now, so the issue with this is, of course, this BNF. By almost no one used as it is because we have problems. Oftentimes it's convenient to have a range, a shorter way of writing things like so people came up with something called extended BNF, right? BNF was like in late 50s, early 60s. eBNF was during 60s. So pretty much every language will use eBNF or something similar to eBNF actually to describe. It's basically more easier to write because we're all lazy, right? So we can define things like add plus minus, things like that. We can add some extra things. All right, so operator expression, right? Yeah, so the question is, so there's no repetition, right? So eBNF lets you do some extra things. So let's see if we can have any more examples, right? eBNF, right? So the question is on ambiguity, unambiguous. I can say that, right? Unambiguous, right? Ambiguous means there are multiple ways of getting there, right? And that's is actually meaning there's multiple ways of getting there. So unambiguous is kind of big deal, right? Your parser, right? There's no easier way. There's no. It's easier way to get to your goal, basically, right? So clearer, right? And easier to implement, right? So let's look at addition and multiplication, right? So this is ambiguous, right? Right. So this is we'll call it expression. Maybe here. Oh, actually, you can see it here. So this rule. Let's check out this rule, right? We have a rule. Expression can be what? E plus E, or some number or ID, right? Again, in this case, ID means a variable, no numbers here actually, right? But of course, you can consider ID instead of ID being letters. It could be also numbers, right? So, but the issue is that these rules, right? What makes an E, right? E could be just single number, right? Unfortunately, there is no plus and multiplication, right? Nobody says, there's nothing that says you have to do it in certain order, right? And that's kind of bad, right? So how would you, if you're coming up with an idea to add multiplication, how would you be more unambiguous? Make sure, right? So you have to add an extra non-terminal, right? We call it, I guess we call it factor, right? Factor will be the whatever we're going to be factoring, right? So expression will be either E plus T or T, right? T can be T times factor or F, right? And this will be now unambiguous. And this is where it gets kind of, starts getting harder, right? How when you're writing a new language, of course, usually for these things you will start by basically looking up examples, right? So let's look at this again. So now there is no ambiguity, right? There's only one way of parsing, right? So this is, you don't really want to define a language using this rule because even your basic syntax checker will break down, basically, right? You will have, you're too loose, basically, right? You'll have basically this essentially means you can multiply or add in any order you want, right? There's no restriction, right? So how to check, right? Basically, you can't. In general case, it actually turns out it's not really hard to find checking whether it's unambiguous. Actually, it's kind of hard, right? But there are tools for that, right? So, yeah, so the good thing is for you, right? You don't have to write parsers if you know how to write these eBNFs. Why? Because there are multiple tools like Yak, yet another compiler, another tool, right? It lets you write the grammar and then you check it basically. Generate compiler, right? So, okay. Now, I mentioned tokens, right? So tokens are things, the smallest units, right? So keywords, if else, and so on. Identifiers, right? Literals, right? Like integers, like floating points. Punctuation, right? So comments, right? How would we add comments to this, to your simple language, right? And let's assume that it's, we want, of course, for that we will need a string, right?
Yes.
Yeah, we will need a string, right? And we will want to add a, well, we are allowed, I believe, I'm not, let's see if I think we are allowed to use multiple characters, in row, even in BNF. You don't have to do a single one, right? So let's add a comment, right? We have our super simple language. Yeah, this one here, right? But we want the comment, possibility of comment, right? At end, right? And basically we would define a comment, right? It's basically we need to have string, basically with all the letters, right? We would need to do this, right? You have to, so you end up doing, so to do a comment, right, you need to do a string, right? String. which is of course what? Or letters, right? Or characters or something like that. So you have to do all these, you know, 0, right? 1, and then, you know, A, you know, Z, and so on, right? You have to do this all for all the characters. You let string, right? And then you have a comment would be what? Comment would be this. Would be, I guess I'm going to cheat like this, right? And then you add string. So notice this means, right, string. So we have defined the comment, right? We say what the comment is, right? So then it's optional, right? So or expression, right? It could be also expression with the comment, right? And I think that's enough. I think we can do this, right? Basically, add here expression, right? On comment, right? And that's it. That's allowed, right? So a single comment, which is basically ends up at being a terminal, yeah. Expression could be just a single terminal, integer with comment, right? So the good news is you're not allowed to use just a plus or minus. It's not gonna lead to that's not gonna be a valid. This language is not gonna be valid, right? You need something between them, right? So this thing takes care of, right? So what else? What else? Right? And again, I'm skipping white space because it's just, again, once you want to start thinking of all these extra things, you end up, you know, your grammar ends up, you end up writing quite a few of these non-terminal rules. But hopefully everyone gets the idea of how you write this, right? So non-terminals, which is basically just a whole bunch of, you know, replacements, you know, building up these things, right? So where we go back to our digit example, I think which was the simplest one, right? Digit or integer example, right? So integer, it could be digit or integer on another digit, basically, right? So now could we come up with an idea? Now that we have all this knowledge, could we come up with a real integer? Right. I don't want to ask LLMs, but they will do this for you now. They're pretty good with BNF, right? So you don't have to do this in your head, but let's see if we could figure this out. We have a leading, so 0 is allowed, but 0,1 is not allowed, or 0,9 is not allowed, right? That's octal. So how could we make this rule? Let me do another paint. Right. Let's see if we can end today's lecture with that, or maybe what else do you want to cover before that? Maybe have some other things to do. So tokenization, I talked about this, formal description. Right. So eBNF, right, lets you have adds extra things like replacement. So grammar for expressions, right? Yeah, this is right. Again, remember this is not allowed, right? Yeah. So no, okay, yeah. So this is eBNF, right? This lets you do it more than once. It adds curly braces, right? And with curly braces, you can keep, basically, lets you keep repeating integers, right? You don't have to do this integer plus integer, right? So this is a final parse tree, right? You end up doing this, right? It lets you that optional, right? And it adds repetition, right? This is repetition, 0 or more times, right? And of course, you can also group alternatives as well. So it's kind of nicer. eBNF is nicer. We'll talk about this next lecture as well. But we still have some issues. For example, we have the dangling else problem, right? So in C-style index, whose else is that, right? Who gets which if using this else? Well, which one? Well, it depends. It depends on your syntax, right? How you define this, right? Well, what's the simplest solution is just add, you require curly braces and you don't have this problem, right? Then you don't have the problem. But if you have a, because again, this is not Python, right? This is sort of like a, pseudo C language, right? Whether else belongs to this one or this one here, right? So again, this would be the inner one. This is probably what I would think if I saw something, some code like this, right? But in some languages, right, you have something like this, right? Using query libres. But again, so explicit scoping, right? Right. Usually closest one. So there's two ways of doing it, right? But formally, right, you can do explicit, basically, right? Now, when there's parsers to do this on, yeah, which will do most of the work, right? So you can check. So the idea is this: you write the grammar, you generate the code, you can check it and inspect it, basically, right? So different tooling has different syntax, you know, how to write this. All right, but we will take a look. Whether there's a really good book which I really like is Crafting Interpreters. If you're serious about this, making your own language, right? Even if you're not, right? Which covers everything in detail, right? But now let's see if we can come up with this non-leading to avoid this 005 problem. Maybe somebody besides me can do this. So how could we do this? We need probably, we could define that starts, well, starts with a digit. Integer starts with a 0. It can be 0, right? Or
I think integer could be integer and digit, and we could include non-zero integer created.
yeah, let's create it. Okay, so let's assume I'll do non-zero. I'll make a new non-terminal. I'll make new non-terminal non-zero digit, right?
Yes.
Non-zero digit. And since I'm lazy, it's basically all of this. I guess I should except the 0. Let's see if we can copy paste. I'm going lazy. Can I do this? No. Oh yeah, I can.
Yeah, you can.
Okay. All right. And copy. All right. And then I'm going to paste it here, right? Can I paste it? Yeah, I can. Okay.
I'll move it.
Oh, and I can move it. Right. Okay. You got the idea, right? Can I make it smaller?
Yes.
Oh, cool. I feel like almost Tom Cruise in what is Minority Report, right? What is movie? There, I don't know.
There's one corner.
Yeah, one corner? No.
I think so.
Oh yeah, I can do it. Phew, cool. Okay.
And,
Oh.
and now integer can be integer and digit, or non-zero integer and digit.
Okay.
Or
Okay.
Non-zero.
Okay. So okay. Yeah. So integer. Oh, right. Ah, come on. Where's my brush size? No. Oh, size. Okay. Yeah. Okay. So integer can be what?
So I would say that at the start you can write integer and digit.
Integer, right? Which is completely fine, right? That's it. Or non.
Wait.
Yeah. Or.
But you have to.
Oh no.
The digit.
I mean digit. I mean it's a. I mean digit. Sorry. Yeah. Right. Right. Or no.
No.
Okay. So integer can be what?
You see the first time when you defined the integer,
Yeah.
there is the second part of integer and digit.
Yeah.
I would say include this, and integer can also be non-zero digit.
Like, do you mean like this? An integer non-zero digit? Or non-zero digit first, right?
Well, I can come up to the board.
Okay, come up with the board.
Just right.
Yeah, because I'm like I said, I'm still
So
slightly jet lagged, so maybe that's my excuse for not.
So I think that we can just
Yeah,
remove this
yes.
and here include the non-zero.
Yeah,
And I think it should check out.
yeah. So it could be because you're not allowed to have just a so.
So from integer you can generate as many zeros as you want.
Yes.
But to terminate the whole integer expression, you have to include the non-zero at the.
But the problem that I see is this is how do you get? Does this let you have 0?
Yes, because at the start you can have digit.
Okay, yeah, but
if you
but the problem is that you still acquire another 0. You see, that's the problem, right? You don't have a rule for. You don't have integer, right?
Give me a counter example where it doesn't work.
No, I'm saying this, right? So the stopping, right? The last, right? What makes an integer, right? So I'm thinking of this example. That's my example. How do you get 0 as a valid? You want to accept 0. You want to accept, say.
Oh yeah, that's a good question.
Yeah. So again, I'm probably we're gonna ask LLM to come up with this, right? But because we want to have addition, so this is slightly there's a trick to this, right? We could. There's many ways of solving this, right? We could, right?
Yeah. I mean, we could. I mean, technically, we just no, that wouldn't work.
Yeah, because you see, we're here requiring non-zero, right?
Yeah, then it would be something more complex.
Yes, we need to come up with things like we can accept, right? So we could say, okay, 0 is. So could we do just a simple? We see if we do 0, right? Then again we end up with this problem, right? So can we remove this back maybe? And just say 0 is allowed, right? 0, right? 0 is allowed, but then
it would create the problem if you start with the second part. Include the integer.
Yeah. So this is again. So this will be maybe again a couple more minutes. Maybe somebody can look up with this solution, right? But you can do this. I can. My brain's slow slightly. What's the word of the day for last year? Is brain rot, right? Yeah, right. 2024, right? Too much. Right. So I'll this over. So what I'll do is so I'll pretend I know what digit and non-digit is, right? I'll do one more paint quickly, right? So we pretend we know what we have integer, right? I mean, we have digit, right? And I'll cheat basically, right? I'll say this, 0, 1, 0, 1, 2, 3, right? Okay. A non-digit.
I think you can invent a new non-terminal.
Yeah, that's the I probably have to do.
That would then.
Right. So we call this. Let's see here. So.
Yeah, I think I know. I think I have the answer.
Okay. Do you want to come up again? Go for it. Right. So we have these two things: digit and non-zero.
So I would create a new non-terminal.
Mm-hmm.
I will just call it
start.
Yeah,
that's fine. Yeah.
Start.
That's fine. Yeah, that's a good.
And then it can be either
0 special case
or whatever previously we wrote.
Yes, special case, and that's it. And that's it. Yeah, that will work because okay. Yeah.
I think it should work.
Yeah. That's fine then. And then we get, it's either 0 or whatever we just defined, basically. Yeah. And then you don't have a problem. So the problem is, you see how dealing with this type of edge cases, your grammar gets quite complex, right? So let me show you what grammar looks like for Python. To end this lecture, we have to, so Python grammar, right? Full grammar specification, right? You will see this, right? So these are the rules, right, and statements, right? You can see this is pretty long, right? All right. So you can see now. You can see what this is a full. You see these are terminals, right? You see the factors, sum, right? Arithmetic operations, right? You can see how is digit defined here. Do they have digit? No, integer. No. Number. Yeah, number. Signed number. Complex number, right? Real number. What the number looks like. Again, remember they're using a kind of like eBNF, but they have specific. They have something. I forgot what it's called. Yeah, it's a mixture of eBNF PEG. It's like a kind of like PEG is another like improvement, right? Or lazier way of writing this again, right? So that it's kind of like a fight between easy to write, right, and short, right? I mean, simple rules, right, and also you want something short, right? But eventually, right? So this stays, you know, or right stays, right? Recursion stays, right? Like assignment, right? I mean, you can see how it's kind of nice, right? Many of these things are nice. Return statement, return on something. Star expression, of course, is non-terminal, right? So delete statement, delete something, right? Import name, right? Import on something, right? Function definition, right? Class definition, right? Yeah. Again, this is just for syntax, right? So yeah. So how long is it? Pretty big, right? Pretty big, right? So we'll look at PG maybe next lecture, but hopefully you got the idea how you could write a very complex grammar using these simple rules. Does this make sort of sense?
Yes.
Okay, let's practice this on Thursday, but more. All right, thank you, and I'll see some of you in the class below, right? Yes. The rest of you I see on Thursday.